Hi, welcome to Moo Moo Math. Today we are going to talk about double angles. So we have three double angle formulas that we're going to work with: sine of 2u, cosine of 2u, and tangent of 2u. So sine of 2u is considered a double angle because we have a 2 or a doubled angle inside of the trig function sine. That's equal to 2 sine u cosine u. Cosine of 2u actually has three different forms. The first one is cosine squared minus sine squared. Second one is 2 cosine squared u minus 1. And the last one is 1 minus 2 cosine squared u. Now notice all the formulas have single angles in them. So what you're going to do is you're going to take this double angle, half it, and half of that angle is going to be in your formula. Then the tangent of 2u works like this. It's 2 tangent of u, which is half of this angle, minus or over 1 minus tangent squared of u. Now we're going to look at where those come from. So today we're going to kind of look at four topics. We're going to look at different ways to prove the double angle formula. So we're going to use identities to do that. The second thing we're going to do is evaluate with double angle formulas. The third topic is solving with double angles. And then the fourth one is just working with identities with double angle formulas. So let's start with topic 1, proving double angle formulas. So the first thing we're going to do is look at where does sine of 2x equals 2 sine x cosine x. Where does this double angle come from? Well, we're going to go back and look at the sum formula. So we need to know the sign for the sum and difference. So let's say we have sine of x plus sine of x. So we have the sum of these two angles because we know x plus x is 2x. So we're just going to write it as a sum. Well, we know that using that sum formula, we've got sine of x times cosine of x. And then sine, for the sine formula, we're going to add plus cosine x sine x. Now, where did this formula come from? It's the sum and the difference lesson that is right before this lesson. It's the first lesson in this unit. Okay, so let's try to simplify this. We have sine times cosine and cosine times sine. Well, that's really the same thing. So we have 2, let's write it as sine times cosine. We have 2 sine x cosine x's. And that's where the formula comes from. It's very simply just the sum formula. Now notice this is a double angle. So let's say this angle is 60 degrees. Well, these two angles in the formula are going to be half of that. They're going to be 30 and 30. Or if this one was 50, you would use sine of 25 and cosine of 25. So it's always half of the angle in the formula. So sometimes you're going to be working with angles and you need to take half of those. So there's where we get the sine of 2x is equal to 2 sine x cosine x. Now let's prove the cosine formula. So as you probably figured out, to find this cosine formula, we're going to go back to the sum and difference again. So we know cosine of 2x, we're going to take this and make this into x plus x. That's just cosine 2x. So we're going to split it into two parts, and now we're going to use the sum formula. Well, cosine is cosine, cosine, sine, sine, opposite signs. So we're going to take the cosine of the first angle, which is x, right? And then times the cosine of the second angle, which is also an x. So we have cosine x times cosine x. Well, that ends up being cosine squared x. Okay, that's the first part. Then for the cosine of the sum, we're going to subtract. It's always the opposite sign from the sum or the difference. And then it's just sine x times, which is the first angle, times sine x, which is the second angle. But since the angles are the same, isn't that just sine squared x? So there we go. That's where this double angle formula comes from. It's just taking a sum formula and expanding it with duplicate angles. Now, this one has different forms. So let's talk about the different forms. We know that cosine squared is equal to 1 minus sine squared because of the Pythagorean identity. So if I want this formula to be in terms of sine or cosine only, I can use my identities. So if I use 1 minus sine squared to write it in terms of sine squared, let's plug that in for cosine squared. Okay, so 1 minus sine squared is equal to cosine squared minus this other sine squared. Well, what does that actually give us? That gives us 1 minus 2 sine squared. So we can write the cosine's double angle formula in terms of sine only if we want to. Okay, now we can also do that with cosine. So there's a second form of it. And again, just like we did a second ago, we can replace sine squared with 1 minus cosine squared, because that's the other Pythagorean identity if we want to change everything to one trig function. So I have cosine squared minus the quantity. Remember, this is a quantity. So what does this simplify to? Well, that's going to be cosine squared minus 1 plus, right? If I distribute it, it's going to be a minus and a plus. So then I end up with 2 cosine squareds x minus 1. So that's the third form of the double angle. So if I want to use only cosines, I use this one. If I want only sines, I use the one I just derived. And if it doesn't matter, you can have a sine and a cosine, you can use this very first one. So there are 3 forms of the double angle. So now let's look at tangent. Now, just like we did the other ones, we're going to take and write tangent as the sum of 2 angles, x plus x. Yep, you guessed it. And then we know the sum of the tangent is tangent plus our tangent of the first angle, x, plus tangent of the second angle, which is also x in this case, is over 1 minus the first angle, tangent of the first angle, tangent of the first angle, tangent x, times tangent of the second angle, which is also x. So what does that simplify to? Well, tangent plus tangent, that's 2 tangents. And then we have 1 minus tangent times tangent, or 1 minus tangent squared x. There we go. And that is where the identity comes from. So that's where we're going to stop this video. And the next video, we're going to go through evaluating. But you've now learned where those formulas, the double angle formulas, are derived.